All right, algebra students. Hey, Mr. Zacek here. Today we are going to talk about how do we solve a linear system by using elimination. And we have a process here, but let's just kind of get into our mind what we're talking about when we have a linear system. We've got two equations with two variables, which is what you see right here. So we've got two equations and we've got two variables, and we need some kind of method. Now, the previous methods that we've talked about, um, we've done so far. Previous methods, or if this is your first introduction to this, other methods, you could label that. Number one is we did graphing, and when we were graphing, we were looking for the point of intersection. And then the second method that we used was substitution. And that's good. Substitution works well when you have an isolated variable. That's a nice setup for using substitution. But a very popular method is called elimination. So when we solve by addition or elimination, both of those words we can kind of use interchangeably. And so that's just kind of the history of where we've been. So let's look at what is the elimination method. Well, elimination, arrange both equations using algebraic methods so that the variables are underneath each other. All right, we'll look at what that is. The goal is to eliminate one variable. That's why we call it elimination, by adding the two equations together. All right. When you add the two equations together, one variable will disappear. Solve for the remaining variable, and then choose one of the original equations and substitute the value to find the other variable. And then we can check both equations. Now, I've got a little song that I sing here, but we'll go through that song here in a minute. It's kind of my own little summary of this. And so here's what we look at. First, you have to manipulate the coefficients to be the same but opposite. Now remember, the word opposite refers to signs. So if one is positive, the other has to be negative. So we're looking for opposite coefficients. So as I look at this first question here, I look at my x's, and I've got a coefficient of 3 and 1. In my y values, I've got -4 and 4, and they're lined up over each other. So first you have to manipulate the coefficients to be the same but opposite. Pause. We're there. Line 2. When the coefficients are the same but opposite, add together to eliminate. Pause. Add together. 3x plus 1x is 4x. -4y plus 4y is plus 0. Don't forget the other side of the equal sign. 10 plus -2 is 8. So, what have we done? We eliminated the y variable, and we've just come up with an equation, 4x equals 8. So there's the third line of the song. So you can solve for one variable. Push pause. We're going to solve for that. Divide by 4. 8 divided by 4, x equals 2. Then substitute to find the other variable. Now here you can pick either one of the original equations. I'm going to pick the second one. X plus 4y equals -2. So I'm going to substitute in for x, 2, and now we're going to solve that. So we subtract 2, get 4y equals -4, divide by 4, and y equals -1. So the solution to the system is the point 2 comma -1. Now remember, if we write it as an ordered pair, we want to write it that way, or we can write it as x equals 2 and y equals -1. You'll see that either way, and you should be familiar with both. All right, so substitute. Now let's check, and then we can kind of review the song again. It's got to work in both of them. So the first equation, 3x minus 4y equals 10. Well, let's substitute. 3 times 2 minus 4 times -1. Does that equal 10? Question mark. So 6 plus 4 equal 10. 10 equals 10. Check. But it's not enough for it to only work in one. It has to work in both. So x plus 4y equals -2. That's the second equation. So when we substitute here, we get 2 plus 4 times -1. Does that equal -2? So 2 minus 4, does that equal -2? -2 equals -2. And it checks out in both of them. Okay, so let's look at that song and let's look at what we did here, okay? First you have to manipulate the coefficients to be the same but opposite. They were 4 and -4. When the coefficients are the same but opposite, add together to eliminate. We did that. That's where the 0 came. So you can solve for one variable. We solve for x, then substitute to find the other variable. We plugged it in and found y. This is how you eliminate to solve a system of equations. Now here's the check. When the left side equals the right in both equations. When the left side equals the right in both equations. When the left side equals the right in both equations. You have the answer. You have the answer. See, I don't know how, and I don't know why. It won't always work out. You could enter it into one equation, it's equal, but the other one won't equal out. When the left side equals the right in both equations. When the left side equals the right in both equations. When the left side equals the right in both equations. You have the answer. You have the answer. Do you have the answer? Okay, our bell is ringing. All right, so I won't sing that whole thing again, but there's the whole song, all right? So let's look now at number 2. First, you have to manipulate coefficients to be the same but opposite. Do we have that? Okay, yes we do. With our x's, we got 3x and -3x. Now, in this case, they're lined up, so we didn't have to do anything with that. So when we add these together, remember there's a 1 in front of the y, so we get 3y plus 0 equals 12. Now, you don't have to write that 0 in, but I just want to show you that when you add something, it's just 0. So 3i equals 12. So when the coefficients to be the same but opposite, add together to eliminate. So we can solve for one variable. We get y equals 4. Now substitute to find the other variable. Pick one of the original equations. It doesn't matter which one you pick. Okay, I'm going to do this first one. So let's do 4 plus 3x equals -2. You're going to subtract 4. So 3x equals -6. Divide by 3. X equals -2. And y equals 4. So our solutions are going to be the point -2, 4. All right, now go ahead and do the check. Push pause. Check it out. See, do you get the left side equal to the right side? Okay, we're back now, and if we checked it out, it should have been negative 2 equals negative 2, 14 equals 14. The left side equal the right in both equations. Okay, let's look now here at number 3. And you've got that one. I'm going to let you do that one. It's very similar. I want to get to a different one here. Now, when I look at number 4, here, let's go back to that first line of the song. First, you have to manipulate the coefficients to be the same but opposite. Now, as I look at this question, I see, okay, we got 1 as a coefficient here. I look at my x terms, and for my x terms, the coefficients are 2 and 2. And for the y terms, I've got 1 and negative 5. Well, you can pick one. In this instance, I'm going to do the first one. And I'm gonna write this down here just because I like a little bit more room to work with this. And I just want you to follow the way that I write this. Okay. What I'm gonna do is I'm gonna keep the top one the same. I'm just gonna multiply by 1, which keeps everything the same. But for the bottom one, I'm gonna multiply by negative 1. Now that's going to make the x value negative 2. So what does that become? Negative 2x plus 5y equals negative 13. Now the thing we got to be careful of is distribute that negative 1 to every single term. A lot of times people fail to get it to the other side of the 13. Now, why do I write it this way? Well, I write it this way so that everything stays lined up. So I really recommend you kind of use this method horizontally of writing it. Now, that's manipulating, using some of our rules of algebra, to get coefficients that are opposites. So again, we've got 2 and negative 2. Those are opposites. So when we add those together, they're going to eliminate. We're going to cross those right out here. And so what do we end up with? Well, we end up with 6y, now carefully your signs, negative 5 plus negative 13 becomes negative 18. Divide by 6, y is negative 3. Now I'm going to go back to the original equation, pick one. I'll pick the first one. 2x plus y equals negative 5. And I'm going to substitute y equals negative 3 in for y. So 2x plus negative 3 equals negative 5. So let's solve that. 2x minus 3 equals negative 5. Add 3. Okay, 2x equals negative 2. You divide by 2. And x equals negative 1. So x equals negative 1. And again, we can write that as an ordered pair. So negative 1 and negative 3. All right, I'm not going to do the check. And I'm going to leave 5 as one for you to do. But we're going to go ahead and, should be, do I have another one? Yeah, down here. Okay. I want to do number 6. Okay. Now, here I've got x plus 2y equals 11, and I've got negative 3x plus y equals negative 5. Now, as I look at these, I see, well, neither of them have the same number in front of them. But the x's have opposite signs. So I got to think, well, what could I multiply that first one by to be the opposite of negative 3? Remember, right now it's a 1. Well, it's negative 3 down here. So if I multiply this one by 3, that would end up being the opposite. And I multiply that one by 1. So let's do that. So we're going to distribute 3, and we're going to get 3x plus 6y. Now here's where you got to make sure, bring it all the way over, equals 33. And down here we're going to multiply by 1, and remember 1 doesn't change any of those values. So negative 3x plus y equals negative 5. Okay, so again, I'm looking for, first you have to manipulate the coefficients to be the same but opposite. So I was choosing the x values here. First you have to manipulate the coefficients to be the same but opposite. When the coefficients are the same but opposite, add together to eliminate. So when we add those together, they cancel out, and we get 7y equals 33 minus 5 is 28. So you could solve for one variable. We only have one variable in this. So when we solve that, you get y equals 4. Then substitute to find the other variable. Let's use that first equation. So x plus 2 times 4. Remember, what does y equal? That's what we're replacing. To substitute to find the other variable. So we're going to subtract 8, and we get x equals 3. This is how you eliminate. Don't forget the parentheses around that point. To solve a system of equations, when the left side equals the right in both equations. Remember, it's got to work out in both equations. Okay, so I'm going to have you go ahead and finish those other ones on your own, the ones we didn't get to, and hopefully this is helping you with solving systems of linear equations using elimination. Bye, guys.